Hey everybody, what we're looking at is the milling machine, and I wanted to do just a quick video here and kind of talk a little bit about some of the tools that I use in the shop. What we're using right now is a shell mill. A shell mill is basically a giant end mill, and it's got teeth on it rather than having just one large bit. And it can actually be changed when you wear out the teeth. It's basically for doing large surfacing procedures. We just swapped over to a 1/2-inch end mill here. This is made out of carbide, and this is for a relief cut that's going to go around the outside of the Mk8 frame. Making Mk8s right now today. This is going to make a big old pass so that we can get a chamfer mill in there and also start to cut out the silhouette of the knife. Anyway, just a really quick video here. I just wanted to show you a little bit of the milling machine working. I'm going to zoom out just a touch and let you see the tool changer work in just a minute. But you can start to see, I don't know if you can, because we were getting a lot of spray here, the silhouette of that knife start to come about. Let's change to a different angle and I'll show you from the other side. Alright, here we are looking through the side port of the Haas VF2. That is the milling machine that I use. It's called a VF2. Haas is an American CNC milling machine company out of California. And in my opinion, they make one of the best CNC mills on the market. They are the industry standard for small machining centers, and most knife makers are using Haas mills or Tormach mills. They're really great for the space. They're actually pretty efficient in terms of size and power. And as far as the cost goes, they're actually remarkably competitive. There are some other Japanese and German-made CNC mills on the market that are pretty nice, but the Haas is everything you need and nothing you don't. And just a fantastic mill. Now I'm getting a little bit of splatter here because we're doing some pretty big cuts there, and it's throwing a lot of debris around. But it's basically just chips of titanium. That's a 1/2-inch end mill in there right now, and you'll see when this goes up to do a tool change, the silhouette of the Mk8 left in the billet. Yeah, I do cut out everything from billet material. You know, if this was an AR-15, you'd be paying a premium for that. Now we're going to grab a chamfer mill and start to work around the edges. Anyway, just a super quick look at the milling machine here. There's a lot of stuff going on. I can't do a really much more in-depth video because obviously I'm having to talk over the milling machine, but it's a pretty cool gizmo, if I do say so myself. So as somebody who's worked with Tormachs in the past, I have to admit the Haas milling machines have got the best coolant system that I've ever used. Granted, that's not saying much because I've only ever had a PC&C 1100, but this is an awesome coolant and debris collection area here. What it does is there's a little corkscrew inside the mill that pushes all the debris into the chute, and it squeezes all the liquid out of it, which falls down into the collection bin, which is actually connected to the coolant system. All the coolant is pretty much self-contained. Unless you have a little bit of a leak going on, you're never really going to spill too much. Granted, you are going to lose some to evaporation and also to other stuff, like, for example, it'll be on your parts when you take the parts out of the mill. But this allows you to recycle the material that's in there, or at least collect it up for easier throwaway. This is really, really valuable. If you've ever used a mill that doesn't have something like this, you'll understand the value of it really quick. And I do have my Strider sticker on there. But I could whack this thing a little bit and you'll see all the titanium falling out there. It's been basically pushed up into the chute here by that screw, and it's ready to fall out into a collection bin. Then we just take that to the dump. Really super easy. Very, very easy mill to keep clean. So this is cool. We're going to actually thread mill. If you ever threaded things by hand or tapped titanium, you'll know that this is kind of a pain in the butt to do. see it move ever so slightly. And it looks like we broke off our tap. Woo! Great. Have to do this again. Okay, well, as inevitably happens, something broke. I lost a 440 tap and also my 1/16 inch end mill. Part of the nice thing about the Haas is they have this little thing here that lets you actually change the tools a little easier. It's really annoying. This is expensive tooling. There's what's left over of my little 440 tap. That kind of pisses me off, actually. I'm running low on 1/16 inch end mills, so hopefully I can get some more of those soon. There is cars too, which is really annoying. This car is pretty much the only company that sells them, and this car is expensive and they're Israeli made, which means that I get to wait 2 weeks before I can get more. So hopefully I'm not out of the count for 2 weeks. Anyway, I'm going to put these in and we're going to measure up our tools and try this again. I'm going to measure the length of this just to make sure that the machine knows exactly how long that tool is, and then we're going to change out for a 1/16 inch end mill. Measure that up. That apparently broke. The weird eccentricities of Haas mills. Sometimes it just doesn't let you take the tool out. Now, tool changes are pretty quick. If you break something, it's just the annoyance of it, the cost of it. Because frankly, these are expensive tools. The taps are the pricey ones. The 1/16 inch end mills are, I don't know, 30 bucks a piece or something like that. The taps are like $100. And, you know, it seems kind of like I'm a little bit blasé about it, but if I could ever actually make any knives, I'd be able to pay for it. But that's one of the costs of being a knife maker. You know, you gotta actually maintain your tooling stock. If you don't do it right, you can be up a creek. You can see right now it's measuring the length. That's an optical tool setter. And now it's going to measure the side so that it knows exactly how much it is. It's going to measure the other side so that it has absolute calibration, and it can compensate for deflection on the little spindle thing there that's actually the measuring device. Alright, we're good to go. Now let's run this procedure again. Maybe this time it'll come out right. Fingers crossed. That's much better. Alright. It worked this time. I think I've probably just had dull tools. Tool 2, which is a 1/16 inch end mill, is responsible for going down into the little hole that's drilled down here for our pocket clip screws and widening it out slightly to accommodate the thread mill. And what I think was happening was tool 2 is just dull or had broken off and didn't actually widen those out. So when I stuck the thread mill down into there, I just snapped the thread mill on. It's an expensive learning lesson, but it is what it is. It looks like, given the finish that I'm seeing on the top of the surfacing job, that it's time to replace the teeth as well on the shell mill. Kind of get a feel for that once you've done enough of these. And I think that's probably going to happen in the next machine job here. Everything else looks good, so we're going to go ahead and go on to step 3, which is going to be the final step. Let's do it. Shell mill first, and it'll do the rest. Oh my gosh, it worked. Excellent. Alright, so we got a Mk8 frame. Sort of. Let me show you what I mean by sort of. When these come out of the mill, that's about half the picture. You know, there's a perception among people that knife makers, especially guys like me who are using CNC equipment, basically just take something out of a milling machine and slap it together, and it's definitely not the case. When this comes out of the mill, this is very, very rough, and it's up to me to hand finish and hand fit everything. You can see that's what's left over. So yeah, I mean, the shape is there. The holes are in the right spots. Everything's threaded and whatnot, and the lock's cut, which is, you know, it's a big part of the process. If you're going to do this by hand, it's quite time consuming. But, you know, there's obviously a lot of work that still needs to be done. So I have my I/O stop on there, all the holes are in the right spots, but I've still got to fit everything together, and still got to do all the blade work and everything like that, which is all done by hand as well. So, that we have a Mk8 frame. So I'm not going to film the whole process here, but I had a customer request a drop point, thinly ground drop point blade on a Mk8. So I'm working on that right now. These are hand ground, and this is what I've got so far. This is, you know, rough ground and whatnot. I'm in the process of finishing it, but you can see where I'm at. Now on my knives, what I do, it's a little different from a lot of people. A lot of people will actually build theirs, and they'll use some kind of jig or whatever to grind their knives. But what I do is I actually CNC machine the rough bevels in here. Now this is not the finished grinds. I count mine as hand ground because I'm going to go back and do a lot of stock removal on top of this. But this is just for me to get a guide, basically. But I'll show you how I freehand from here. I'm using a Beaumont KMG, by the way. That's this grinder, which is probably one of the better grinders out there. Wilmots and Burr Kings and stuff like that are really nice too, but I just have the KMG because it's like the AK-47 of grinders. It's pretty much built like a tank, and it takes a lot to keep one from working. Anyway, I'm going to show you how I grind this. I'm going to go up to about 600 grit or so, and then I got to actually figure out what my guy was looking for exactly. I don't do custom orders, but I try my best to take into account what my customers are looking for. You know, if somebody tells me I would love to buy, you know, a stonewash blade that's two-tone or whatever, I'm going to try and actually fill that need because I know there's a demand for it. So it's smart business practice. But anyway, here let me show you how I grind this stuff. You know what? I've learned my lesson. Eye and face protection, definitely a must for this particular machine. This probably isn't going to look too different to you, but to me it looks much better. We're up to 450 grit. I'm going to go all the way up to 600. You can see me, if you looked at what I was doing, I was actually reading the water. If you actually dunk this in water and you let it kind of drip down, you can see more readily the areas where it kind of hangs up a little bit. That's where you haven't reduced the friction on the blade. In other words, you haven't ground there, and you need to concentrate on those kind of spots. And you learn over time where you need to put pressure and whatnot. This is what true freehand grinding looks like. It's a meticulous, difficult process. You have to be very skilled to do this and do it properly. You know, a lot of guys are using jigs, like I said. That's definitely a way to do this and eliminate some of the human factor here. But in my opinion, this makes a far more beautiful blade. You don't get that sort of abrupt transition with the plunge lines with this. You get a much more organic, flowing plunge line. And in my opinion, I think it looks really good. You can also kind of grind angles and whatnot and curves and things like that if you're good at it. And once you get more steady-handed, this to me is a much more beautiful looking grind. At the end of the day, that's part of the equation here, so I like to do my, my blades freehand like this. Anyway, I'm going to go ahead and finish this up and show you some of the reshaping on this. We're going to make this actually into a drop point, and you know, I use one common blade blank that I make, and then I shape everything to whatever I need. Just a little bit more economical way to do it. Instead of making purpose-made blades, it's a little bit more handwork, but it works. Okay, here I've moved over to the flat grinding plat, and I'm going to go ahead and reshape this blade, and this one's going to become a drop point, and I think I'm probably going to put a swedge on it to thin out the tip just a little bit. Otherwise, looking pretty good. This is a very thin edge. I think the guy who made the request on this knife is going to be really happy about that. Anyway, I've got to make it into a drop point now, so I'm going to actually kind of reshape the tip a little bit, and we'll go from there. Looks good. So at the end of the day, that's kind of what our finished product is going to look like. Now there's a little bit more handwork that's going to go on here to get this to where I want it to be. But you can see we've got our swedge in there, a little bit of a swedge. Just real subtle, but it's enough to thin out the tip. And we've got a nice hollow hand ground blade. Gorgeous. Now that would be satin. Now if I were going to do this in like a real satin, I'd take my Scotch-Brite belt and actually go through it there, but I'm actually going to do two-tone finish on this, and it'll look a little bit different. I haven't decided what kind of two-tone. Might be hand-rubbed bevels with polished flats. I don't know. We'll see. Thinking about doing something kind of cool though.